dear students. My name is Dr. K.C.H. Apparao, working as an associate professor in Mechanical Department, Institute of Aeronautical Engineering, Hyderabad. In the previous class, we discussed the just a brief description or brief introduction about the optimization techniques or operation research. Okay. So in last class, we already discussed what are the important tools which are used to solve the uh, different problems by just like in operation research subject, in which the first one is the linear programming. Okay. So in this class we'll discuss about the what is linear programming problems, and what is the basic terminology, and just what are the applications of linear programming, and what are the advantages and limitations of linear programming. So last is the how to formulate of linear programming models. It is the formulation of a problem, just like conversion of the problem to uh, linear programming models is very important. So it means how to formulate the LP models of the problem. Okay. So we'll see first of all introduction of the just like linear programming. Okay. So each and every organization just like aspects of optimal utilization of its limited sources. We know that source nothing but men, money, and material, and machines, and methods and time. Okay, to reach the targets mainly. So the results are generally measured in terms of just like profits or losses, cost basis losses, just like production basis, just like profits, and returns on money invested, etc. Just like either profit or loss, just like returns on money invested. So these are the three terms. Okay. To achieve these results, okay, decision maker has to just a thorough knowledge about the tasks or the jobs and the relationship among them. Okay. So among the popular techniques of operation research, so mainly just like linear programming deserves just like very important technique, because it is the one of the widely used technique in operation research. Okay. So in other words, just like LP is the one of the most important uh, research tools, operation research tools, mainly used to allocate the scarce just like sources in optimal way, so that the allocator can optimize the results. Either it is the maximization of the profit or minimization of the cost. Okay. So just like minimum resources, allocation of minimum resources in optimal way, it is a very important point. Okay. So the credit of innovating this technique goes to mainly George B. Tangent. So he is the inventor of this technique. So he innovated this technique while he was working in the US Air Force during the World War II. So in 1947. Okay. So initially this technique was used to solve the thorough logistic problems, just like assignments and transportations. Okay. So assigning of just like mission to operator and transportation, cost minimization in transportation. So, but instantly the application of this technique has spread almost to every functional area of management, production planning, and just like production control also, personal management also, and next to advertising and promotions also. So in every area, just like you can apply this technique. So just like to get the optimized profit maximization or just like cost minimization. Linear programming decisions are made obviously under certain conditions mainly. Okay. So when the existing situation and the variables are known, situations and variables are known. And so the results obtained will be either just like optimal, near optimal. Okay. It even helps in the cross verification of the results which are obtained through the process where institutions and the one arrived with the use of linear programming techniques. Okay. Well, an optimal solution is being anticipated. Okay. So the general linear programming problems call for optimization of minimization or maximization here, linear function for a variables, just like those variables are called simply objective function. Okay, that's subjected to set of linear equations or inequalities. Those are called the constraints or restrictions. Okay, so it is used to describe the relationship among two or more variables. Okay, so which are directly or precisely proportional. Okay. So next to programming means the decisions which are taken systematically by adopting alternative course of action. Okay. So these are the basic requirements and their relationships. These are the very important. The first step, first point is the decision variables and their relationships. Okay. So these are the important. The decision variables refers to just like any candidate, either person, service, project, or jobs or tasks. Okay, competing with other decision variables for the limited sources. Just like so, these variables are usually just like interrelated in terms of utilization of resources and need. Uh, Simultaneous solutions. Okay, so it means just like a relationship among these variables should be linear. So next function is next one is the objective function is very important. Just like the linear programming problem must have a well-defined objective function to optimize the results. Just like for instance, so minimization of cost or maximization of the profit. It is the objective function. So it should be expressed as a linear function of decision variables. Here decision variables are x1 and x2. Okay. So z is equal to just like something into x1 plus and x2. So here z represents the objective. Okay. So it means minimization or maximization of the x2 and x1 and x2 are the decision variables directly affecting the z values. So z is mainly depend upon the just like x1 and x2, just like which are the variables. Okay. Next one is the constraints is very important. So there would be a limitation on the resources, just like which are to be allocated among various computing activities. Okay. So these must be capable of being expressed as a linear equation. So those constructions are converted into just like linear equations. Okay. So next one is the alternative course of action. Fourth point. So there must be just a presence of alternative solutions, just like for the purpose of choosing the best optimum one. So next one is the non-negotiable restrictions. So next one is the linearity and divisibility. So you have to consider all the parameters. We'll say just like what are the main steps which are involved in the linear programming. Just like this, so these are the applications of linear programming. So you know that it is the LP has the widely used in the techniques of war. Almost every decisions of a business and management. So however, linear programming is extensively used in the just like production management and personal management, financial management, and marketing management. So in all these sectors, just like LP is using effectively. So before that, just we will see just advantages and limitations of linear programming also. Okay, it helps in proper and optimal utilization of the scarce resources, just minimum resources. So how to utilize these scarce resources in optimal way. So that is the advantage. So next one is it helps in improving the quality of decision. So for the decision making also it is helpful. Next with the use of this technique, so the decision maker become more objective and less subjective. So that is the one more point. So it even helps in considering other constraints operating outside the problems. So next, many a time it hints the just like a manager about the hurdle faces during the production activities also. So these are the main advantages of the LP problems. Okay, so see, these are the few limitations here also given. The just treatment of variables having non-linear relationship is the just greatest limitation of this LP. So it can come out with non-integer solutions too. So which would be time meaningless. Just like, so next one is it rules out uh, just like effect of time and uncertainty conditions. So last one is the large scale problems tend to be unaccommodated to solve this LP problems. These are the just like few limitations of this process. Main steps to formulate the LPP. The first of all is the identify the nature of the problem. It means either it is maximization or minimization of the problem. So profit wise, so that is the maximization. So just like cost wise, that is the minimization problem. So next one is the identify the number of variables to establish the objective function. Okay, identification of variables x1, x2, x3. Just like next, formulate the constraints. So conditions you have to formulate. Next, develop non negativity constraints. These are the steps how to formulate the LP models. The first step is the just like it gives the situation to find uh, key decisions to be made. Okay. Second steps, identify the variables involved and designate them by the symbols, just like x, j is nothing but 1 or 2, 3. It means x1, x2, x3. These are the just like variables. So step 3, state the feasible alternatives, which are generally just like xj zeros. Okay. So next, third one, fourth one is the identify the constraints, the problems, and express them in the linear equations. Okay. So fifth one is the identify the objective function and express so it has a linear function of the decision variables. Okay. So we see it's in numerical, then we can understand clearly. Okay. So this is the numerical. A company produces two types of hats. Each hat of the first type requires twice as much labor time as the second type. It means first hat takes double time compared to second type. So if all hats are of second type only, the company can produce a total of 500 hats. So this is the condition is given. So next, the market limits daily sales of the first and seconds. So these are the constraints. So 150 hats you can manufacture. You can say hat 1. So 250 up to 250 hat 2, so we can say. Next, assuming that the profit per hat it is the 8 rupees per year type A and 5 rupees for type B. Okay. Just formulate the problem as a LP problem. Okay. So first of all, we have to consider decision variables. Okay. So first one is the x1, just the number of hats of type A. There are two types only, type A hats, type B hats. Okay. So number of hats of type A, say x1, and the number of heads of type B, say just like x2. Okay, so next to go for the objective function, just like here. So objective function, you know that the profit on hat A is the 8 rupees. So 8x1 will be the profit on hat A. Okay. So just like next to profit on each hat B is the 5 rupees. So total hats profits are the 5x2. So uh, B model type. So here the total profit will be just like profit. So we have to maximize. So that is equal to 8x1 is the just a profit of hat A, and 5x2 is the profit of the xb. Okay. So this is the just like objective function, that is equal to 8x1 plus 5x2. Okay. Total profit. So next to constraints. Okay, so it is the time constraints, machining time. So here one condition is given. Each hat of the first type requires twice as much the labor time of second type. Okay. So if you all hats of the second type only, the company can produce total of 500 hats a day. Okay, so in which this is the B type of hats. So to produce the just like A type takes the double time, just like 2x1. So this is the 2x1, this is the 2x2. So total time is, this is the just like um, less than or equal to 500 as per this condition. So 500 hats. Okay. So this is the constraint one. So second constraints we will see just like so this type of hats. Uh, First type of hat. So the market limits daily sales of the first type of hat is the 150. So it means X1 hats, first type A type hats less than or equal to 150. So X1 less than or equal to 150. So that is the so type 2. The market limited daily sales of the second type of hat is the 250. It means x2 less than or equal to 250. One more condition. Okay. So finally these are the just like LP problems. So it means the problem is converted into LP model. So that is the Z equation, that is the maximization optimization function, just 8x1 5x2. So Z max. Okay. Constraints are the first condition 2x1 plus x2 less than or equal to 500, and x1 less than or equal to 150, and x2 less than or equal to 250. By using these linear equations, we can solve the problem, and we can uh, give the best optimized profit range. So for that numerical. So that is the in this way, just like we will solve the different numericals, different problems which are facing in different sectors. So this is the one more numerical. A transport company has two types of the truck. So type A and type B, two types of the uh, trucks. So type A has a refrigerated capacity of 20 meter cube, and non-refrigerated capacity is 40 meter cube. Next to type B has the refrigerated capacity of 30 meter cube, and non-refrigerated capacity is just 30 meter cube. Okay, so a grocer needs to hire trucks. So for the transport of the maximum range is 3000 meter cube of refrigerated stock, next to 4,000 meter cube for the non-refrigerated stock. The cost per kilometer of a tire A is the just like $30, and for the B is $40. Okay, so how many trucks of each type should the grocer rent to achieve the minimization of the total cost? So cost oriented restrictions. So formulate the mathematical modeling LPP. Okay, so first of all, X1 or X is the number of types of a truck A, and Y is the number of types of the truck B. Okay, so minimization condition, that is the just like so this is the so first of all, cost per kilometer, that is the type A cost is the $30. So 30 into x 30 into x, and just like for type B, so that is the $40, 40 into y. So this is the total cost. So you have to minimize this total cost. Okay. Constraints. So what are the constraints? The first of all, first constraints, refrigerating capacity and non-refrigerating capacity. It is the total 20 into x for the just like refrigerating capacity. That is the just like 20 refrigerating capacity of A is the 20 meter cube, and just like for the refrigerating capacity is the just like 30 meter cube. So 20 into x and 30 into y. So less than or equal to, so greater than or equal to just like 3000 to refrigerating stock. So in this way, now for the non-refrigerating system, that is just like 40 non-refrigerating capacity is the 40 meter cube for the just like type A, and just like 30 meter cube for the type B. So 40 into x plus 30 into y greater than or equal to 4000, that is the capacity. So 4000 meter cube of the non-restricted stocks. These are the greater than or equal to 4000. So by using these just like equations, so we can solve this problem. So here just like x and y is the always greater than, so because there is no negativity. So in this way, just like we can convert this total problem into mathematical form. So by the help of different techniques, we can solve this mathematical forms, and we can obtain the, and we can get the desired optimal level to minimize the cost in this area. So in this way, just like we can solve different numericals. So we can formulate the problem into mathematical modeling. So to solve this mathematical modeling, there are so many just like types of method, just like simplex method, just like graphical method, and just like big M method and dual method. So there are so many types. Okay, just but conversion of the problem into LP models is very important. This one is the one more numerical, just like just see. So a store wants to liquidate of 200 of its shirts and 100 pairs of the pants from the uh, last season. Okay, so they have decided to put together two offers, just like A and B. Offer A is the package of one shirt and a pair of pants, which will the cost is the just like $30, and offer B is the package of three shirts and a pair of pants. So cost is the 50. So first cost is the 30 and second cost is the 50. Okay, then objective function is the just profit maximization, that is equal to, so first of all, x is the number of packages of offer A, and y is the number of packages of the offer B. Okay. Then z is equal to first of all 30 into x plus 50 into y. So that is the just objective function. So here objective is the maximization objective. Okay, constraints here. First constraint, that's the one shirt and a pair of pants. So 1x plus 3y less than or equal to just like 200. Right? So this is the final value. Okay. So next second one is the x plus y, second pair is the just like mm, offer B is the package of three shirts and one pair. Three shirts and one pair. So that is the 200. Okay. Three shirts and one pair. Okay. 3x and plus y just less than or equal to 100. So here just condition is x greater than or equal to 20 and y greater than or equal to 10. So x and y always the greater than 0. So this is the, in this way just like we can convert this numerical into mathematical forms, and we can solve the these mathematical forms by different methods, and we can give the just like optimized values, so to increase the uh, to maximize this profit. So in this way just like we formulate the different any type of problem into LP models, and we can solve LP models by different modes. Okay, so in next class we'll see how to solve these LP models by different methods. So what are the simplest method, and just like a begin method, or just a graphical method. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.